The question is asking us to find the volume of this load carrying part. So not the front part, just the back part, which is simply a cuboid, and the volume of a cuboid is the three dimensions just multiplied together. So it's 4 times 2.5 times 2. But I wouldn't just write this here, I'd have to write V equals just so that I can be clear about what it is I'm trying to find. And then by multiplying them together I get 20, and the units can be seen here, meters. But because it's meters times meters times meters, it's meters cubed. The second works example is referring to a cylinder. And to find the volume of a cylinder is the surface of the cross-sectional surface area, which is the pink area, and then multiplied by 60. So the volume is equal to pi r squared times 60. But be careful here, the radius isn't 20, it's 10. So this would be 100 pi 10 squared times 60. And I could leave that as either 6,000 pi or 18,850 centimeters cubed, and that is to the nearest centimeter cubed. This is what's called a prism, and that's spelled like this, prism. And that's where you have any shape, any 2D shape that has been stretched into a third dimension. And this is what we have in our third example, which is a triangular prism. And it's called a sleeping policeman or a road bump, or those just annoying things you have to drive over. And it's made, in this case, of concrete, and the dimensions are shown in the diagram. But to find the volume of the concrete needed to make one of these, it's simply just going to be the area of the triangle here. And then once that area has been found, you multiply that by the 300. So the volume is equal to the area of the triangle, which we know is a half base times height, and then we'd multiply that by 300. I can halve the 80 to make 40. 40 times 10 is 400, and then multiply that by 300. This would give you 120,000 centimeters cubed. Simple, really, but now it's your turn.